Hello.
Hi.
Hi.
Hi. Oh, this is great. I've never done a group Skype communication like this. This is wonderful. Wow. So you're waiting for a couple more, or?
Yeah.
Okay. So all of you go to the East Chapel Hill High?
Yep.
Yeah, in Chapel Hill, North Carolina.
North Carolina, yeah. I'm way out in California.
Oh.
Well, maybe while we're waiting, you can tell me a little bit about your project. I got a brief description. It sounds really interesting, especially to me because I'm not much of a microbiologist. So,
do you want to explain it, Cecilia?
Yeah.
Well, we're going to engineer E. coli using a riboswitch. It's a strand. It's like a structure of mRNA that regulates gene expression. So we're going to use that so that we can basically tell it to remove excess fluoride from water, because it's turned on when there's excess fluoride. So once
so it just takes it up into its body, I guess, right?
Yeah, it's like attached to it. Yeah.
Oh, interesting. That is brand new to me.
Yeah.
Has it been tried before?
No.
Well, there were studies that showed that bacteria could be a good way to bioremediate fluoride from water, but I don't think anyone has really tried to do it.
Yeah. That's a fascinating idea. Yeah.
And we're working with our mentor, who is a postdoc at UNC, University of North Carolina.
Is that Joseph Harrison?
Yeah.
Yeah, right. So I wrote down some notes, and I thought this sounded really fascinating.
Yeah.
So good for you.
Okay.
So is this something the students create? Do all of you are responsible for creating the project, or how does it work?
Well, at the beginning, we all worked on brainstorming ideas, and we pitched them to our mentor, and he would tell us, which ones are cheap or actually possible to do, in terms of finances and equipment that we have.
Right.
And our right level, since we're first year team, so we don't know a lot.
Yeah.
So which one would be most viable for us high schoolers to execute?
Right.
Yeah.
Right. Well, it's fascinating to me because fluoride, you can't filter it out of water. It just runs right through filters.
Yeah.
So that's one thing that makes it hard to remove. And processes that have been used, like reverse osmosis, are very expensive for poor communities.
Exactly. Yeah, that was one of our questions.
Yeah, so when I was working, which I hope to continue with, we were financially constrained pretty severely. So that's one of the questions, is how to make something kind of effective that the community accepts, that doesn't cost a whole lot, and that can be maintained without a lot of really advanced training.
Yeah. Should we start now, I think we can start, right, Cecilia?
You want to try calling them again, or what you said?
Yeah,
one more person?
let me text them.
Okay.
So, Miss Craig, what is it that you work with again?
So I've been working on a project. So my background is in water resources and water quality, and I was trying to find a cheap way of removing fluoride in a rural community of northern Ghana, which is in West Africa, that was using mostly local materials. So what we were trying to do was, we started off trying to use local rock that fluoride attaches to, absorbs to. So that was what we thought would be great, because it's the most abundant in the community. But we found out some of the issues were that absorption, I don't know if you guys are familiar with absorption. It's basically the ion attaching itself to the rock. It's pH dependent. So
Oh,
for
yeah.
fluoride, it worked. You know about that?
Yeah, we actually just we were doing some tests with plates and stuff, and then we found out like Delta CRCB, it's a type of E. coli strain that doesn't have the fluoride channel, so
Uh-huh.
it's and it should be like not growing because the fluoride is supposed to kill it when it enters it. So because it can't pump out the fluoride, so it's supposed to die. So it's not supposed to grow. But then we found out that it was growing. But what we found was that right next to the CRCB was the wild type E. coli, which is the regular E. coli, and it was we found out that the wild type was changing the pH of the agar on the plates, so it was allowing it was becoming more basic so that the fluoride can't go in. And like as you know, it has to be like slightly acidic in order for it to like enter through the membranes. So we found that out recently, and we were really excited about that. So
yeah, now we have to like we're thinking about having we might need to require like a buffer with a lower pH to make our like results like more effective. But we're really excited that we like figured out that was the pH that was sort of affecting everything.
That is huge, right?
Mm-hmm.
Yeah.
And it's interesting that you're finding the same kind of reactions with the bacteria, because in mine with chemical absorption, that's the same thing, that the pH, it works best if the pH is on the low side. Otherwise, the absorption doesn't attach to the rock very well. So my biggest problem was in the groundwater, the pH was a little bit too high naturally to work very well with the local rock. For example, the groundwater pH was a little above 7, maybe 7 to 7.5, and the rock worked best at pH 4 or 5. So you would have to lower the pH dramatically.
Oh, wow.
So that added a step to the process that would have made it more difficult, at least at the local level. So that is one thing that we found that didn't work as well. Plus, we realized we'd have to use so much rock. There were not a lot of, so they have a specific number of absorption sites. So the fluoride attaches to little sites on the rock, and it depends on the surface area of the rock. And we didn't find that the surface area was high enough to allow enough absorption sites. So then it would become saturated really fast, and we'd have to keep changing out the rock on top of the pH. So we found it wasn't really very practical.
So you plan using the rock to absorb some of the excess fluoride?
Yeah, adsorb with a D. So if you look up in chemistry adsorption processes, so often it's by ion exchange. So the fluoride would kick a hydroxide. So fluoride has a -1 charge, which you may know, and a hydroxide has a -1 charge. So what often happened is the fluoride would exchange with the hydroxide on the rock and kick the hydroxide off, and then the fluoride would attach. So at very high pH, that means there's more hydroxide in the water, so it would outcompete the fluoride. So that was part of the problem with the rock. So at the lower pH, there's less hydroxide in the water, so it's easier for the fluoride to attach. But in your case, it's interesting that you found that it wouldn't cross the membrane. Is that what you said?
Yeah.
The higher. Interesting. That's really fascinating.
Yeah.
So, do you know any more details, or that's all you know so far?
So far, that's all we know.
Yeah. What's going on? Hi.
Hi.
Hi. Okay, so I guess we can start.
Yeah.
Okay.
So again, just talking about, we plan to create a biosensor using the green fluorescent protein. We have 3 systems. So GFP is one of the systems. And that green fluorescence protein would, light up to detect high levels of fluoride, or when high levels of fluoride are present. So before we did any of our lab work, we had to, conduct research before doing that. This is what we would spend the next year working on. And we use your study as one of those tools to provide context and other information on how to best tailor our riboswitches in the real world. So to begin with, I guess I can ask the first question. In your study, pond. Peter? Okay. So in your study, you mentioned that in Ghana, all the water sources are decentralized and all residents rely on community hand-dug open wells or borehole drilled hand pump wells. Is that community's preferred source of water? They contain less sediment and they're less prone to microbial contamination, and the water is easy to collect. However, they also have the highest average fluoride concentrations, 3.4 to 4.5 milligrams of fluoride per liter. And you predict that there will be many more cases of severe dental and skeletal fluorosis in the coming years because these systems were installed relatively early, like 2008. So I wanted to know, like, why do the hand pump wells have so much less contamination in terms of sediment and bacteria, yet they have higher fluoride contamination than the open wells?
So the drill borehole wells are quite deep. So one good thing about the very deep wells is that actually when water, rain, and water seeps through the ground, they're actually, if there's microbial contamination coming from the surface, like from manure, it actually, by the time, it doesn't reach that depth, or it's broken down. So it actually acts as a filtration system. So the shallow open wells are very close to the land surface. I mean, they were more common just because you could dig them by hand. They're more susceptible to contamination from the surface, and they don't have that extensive filtration system that the drill boreholes at greater depth have, which might be 30 meters deep or more. So, and also, because of that depth, they contain less sediment. You know, you see surface water can be kind of murky, and you might even look in a big open well and it can look kind of murky. But I think at the greater depth, just pumping from the aquifer directly and the filtration system, natural filtration system, actually provides in general a higher quality of water. So that has always been the positive side of these deeper boreholes. On sort of an aside, but something similar, what happened in India is a bunch of deeper boreholes were drilled because the shallow surface water in shallow wells were causing a lot of contamination. It was causing diarrhea in babies, and it can actually kill them. So they drilled deeper boreholes because they're cleaner, but then they found they had naturally occurring arsenic, which was actually causing cancer. So they had it, and that was coming from the rock. So they created a new problem. So this is similar with the fluoride, that the fluoride comes from the rock. So at the greater depth, the shallower wells may not be tapped into the fluoridated rock, and the shallower wells may be a little bit diluted by the rainwater because they actually are so influenced by the rain. They fluctuate when it rains. The deeper wells we found had higher concentrations of the naturally occurring fluoride from the Bongo granite.
Okay.
As the travel time, as water travels through groundwater, the chemistry of the water evolves as there's dissolution and precipitation. So we found that as a result, the deeper wells generally had higher fluoride, which is too bad because they're otherwise cleaner.
Yeah.
That was the problem. And like you said, they're so much easier to collect water because you just pump into a bucket instead of putting the bucket into the well and lifting it out.
Yeah. That was another thing. Like in terms of how people get their water, like because I assume that, like, how many wells are there? Because, everyone in the community needs water to cook and clean and bathe. So what's, like, the methodology that people collect their water?
So, you mean what device? Well, they have to so some are lucky and the well is very close to the house. And they collect them, and so it depends. So the houses are dispersed. They're farmers, so they have land around their house. So they don't live clustered together. They live around their land. So even though there are a lot of wells, most people have to go at least, maybe 400 meters to get their water. Now, in this community, they've been lucky. They've worked hard to install more wells so they don't have to walk as far. But the ways they collect their water, for those who have to walk a ways, they often will come with a cart that might be pulled by a donkey, or even just the children pull it, and they have a bunch of these huge jugs, maybe 10 of them, because the families are large. And they might just spend the morning filling those huge jugs and then rolling the cart back to the house. So that's one way that people do it.
Okay.
Where I was living, we were lucky, and we had a borehole right outside our house. So we would just walk outside our house and walk 20 feet and fill it up. Yeah. But we noticed that there were people coming around this well because it was easy to get to from the street, and they would come with their carts.
Okay. So were there like
sometimes? Excuse me?
Were there like lines? Like, do people line up and wait their turn?
Yeah, it wasn't too bad in this community because there were quite a few boreholes. But yeah, there would be, there could be maybe 10 people waiting, to fill their jugs, depending on the time of day. Yeah. I mean, which I'm sure that's an ongoing problem in these communities, is the amount of time they spend collecting water. And it's generally children and generally girls that do it.
Okay. So this is kind of like something I noticed, but you said initially to check the fluoride concentrations and samples of water taken from like the wells, you used an Orion 4-star meter and fluoride ion selective electrode.
Yeah.
Like, was that easy to use, or what other methods of measuring fluoride, removing excess fluoride exist on the market currently? And
it's actually really oh, go ahead. I'm sorry. Go ahead.
Are they viable for use in developing countries like Ghana?
It is easy to use, and it's quite accurate, and it's expensive it's about, let's see, the electrode itself is several $100s and has to be replaced every year, and then the device that attaches to, I can't remember what I paid, it was probably $800. So it's a very good device to use, but you really have to be connected to some kind of organization that can pay for it. And you do need some technical training. So it would be nice if there were a cheaper and easier way to identify fluoride concentrations. That's been another question. Is there an easier and cheaper way to identify, the range of fluoride concentrations in drinking water?
Okay. So the World Health Organization recommends a daily fluoride limit of 1.5 milligrams per liter. However, in your study, you recommended a dose of 0.6 milligrams per kilogram of body weight. Is that, which you said is the optimum for preventing severe dental fluorosis and maximizing dental caries? So I wondered, I think you also said that this would apply just to younger children, realistically, but in a perfect world, would you like to see this implemented for all ages?
Yes, and the person whose work, I'm sorry? The person whose work I built upon was Brima Upambiri, and I actually took my work and took his PhD, his dissertation, and built on. He's from that area, and he was one of the first people to identify high fluoride. And he didn't measure water concentrations. He didn't measure how much water people were drinking. He just estimated it, and his recommendation was 0.6 milligrams per liter for everyone. So I thought that sounded good, but I wanted to get actual measurements. So I actually think it would be ideal if that were the limit for everyone, for adults and children. I think that would be ideal. the problem is the lower the limit, the harder it is to reach that limit, and so that means it increases the cost of getting a good filtration system in or fluoride removal system in. So my compromise was maybe focus on young children, because dental fluorosis occurs, the teeth become damaged when they're developing. So children are most vulnerable to dental fluorosis because the teeth are still developing. So I thought if you really want to be a little more cost effective, you could focus on having very low fluoride water for younger children, and then not worry about it for adults and maybe teenagers whose teeth aren't developing anymore. Then the 1.5 would be okay. But Brima said, well, that's going to be difficult to do, to have two standards. So that's from a practical level, that's difficult. But maybe the parent could just try to focus on having lower fluoride water for their very small children and not have that something that's enforced. That's why Brima recommended the 0.6, just across the board it would be easier. But then it felt a little bit more difficult.
Okay, that makes sense. So in your study, you do not address other health impacts of consuming excess fluoride, including reproductive and developmental changes, neurological effects, and impacts on the immune, gastrointestinal, renal, hepatic, and endocrine systems, and carcinogenity.
Yeah.
So your study, I think, was published in 2015. Have you learned any new information regarding these health impacts?
I haven't.
Okay. And what is your opinion on controversial studies which show links between depreciating IQ scores amongst young children with consistent exposure to toxic levels of fluoride?
You mean, do I think it's relevant or true or relevant? Yeah, I think it's important. I think they're very important to address. Very important. I just couldn't comment because I didn't have enough information to comment either way. But I think that's extremely important to address.
Yeah.
I lost someone.
Sorry, I'm charging my phone and I can't.
Yeah, I think it's very important to address.
Okay. So you claim that there's no effective way to prevent fluorosis that is also cost-free, and our aim is obviously to turn our project into a bioreactor that can bioremediate fluoride, as well as a biosensor that can detect excess levels of fluoride, all at a low cost. What do you think is the best way to make use of this mechanism if successful? How do you suggest that we can safely incorporate this in underdeveloped countries where overfluoridation is an issue?
That's a good question. Yeah. Well, you mean how to introduce it so that they will accept it? Or
also, because we're afraid that the community might reject it, with the case of golden rice. And how to address their concerns and make them feel safe, I guess.
Yeah, no, that's right. That is a very good question, and it's very complicated. And even as I was collecting data, my perspective was changing because, for example, in my experience, I found that most people didn't even know what was causing fluorosis. And here I was, this white lady coming from nowhere telling them that something in their water is making their teeth brown. And they said, the water looks great and it tastes great. I mean, some of them probably thought I was nuts, So the first step I found is if they don't understand within their own communities what's going on, this will never be, you can't sell it to them if they don't understand it. And it's not that they're stupid, it's sort of weird. I mean, it happened to us in the United States when we first had fluorosis. People did not get what was happening because the water looked and tasted perfectly fine. So the biggest problem, I think, you got to start with education to get people to really understand what's going on and get them to believe it. And that has to start from the community. All this stuff has to start from the community. I mean, people really need to sort of own this stuff themselves. Yeah. And that is a difficult thing. I've spent almost a year in my community, And I still felt like I was getting to know people. This takes a long time.
Mm-hmm.
So I think part of it is getting them to understand it. And then the trickier part is something like this might be acceptable if it doesn't, if you tell them it's bacteria that are cleaning up the water, it depends upon how well they understand the bacteria, because a lot of bacteria cause diarrhea. You know what I mean? Like another example is in East Africa and some other countries, they found that bone char, so these bones actually can remove fluoride. And so in some East African countries, what they would do is they would take cow bones or animal bones and cook them so that they char and become a powder, and would use that to clean as an adsorbent to clean the fluoride, to remove the fluoride. And that gave some people the creeps. Like, we're not going to use, bones of dead animals to clean our water. And if you didn't cook it well enough, it gave the water a funny taste. So there's always that fine line between, introducing something new that, if done properly, does a good job. But if not presented properly, you can just lose them. So that's something that I found I don't think you can answer until you spend some time with people and introduce something slowly. I mean, there was a similar problem when we were trying to use this rock called laterite to remove the fluoride. And people were like, that's gross. You're using a rock to clean our water? We don't want rocks in our water. So that also had success. It didn't work anyway, I don't think. I don't think it was practical anyway. But all of these low-cost methods, many of them are met with resistance. So, I would be really interested in seeing how it could be incorporated. But that's a tough one always.
Mm-hmm. So, like you were talking about with educational programs, like that being the most effective way to get people on board. Human practices, like this sort of stuff, like creating educational programs to inform the public is like what iGEM really wants to see us doing.
Yeah.
So, in order to educate the public, what do you think would be the best way? Should we have PowerPoints? Obviously, I don't think there's much technology there. Or maybe, creating little pamphlets and printing them and distributing them there, or talking to a local governing person or someone in power. What do you think is the best way?
Yeah, I think in a lot of these rural communities, at least where I worked in West Africa, I probably would not do the PowerPoint or the pamphlets. A lot of people don't read. It's a very oral culture. And I know the way they help each other, they have town meetings and stuff. And I would think it would be best to probably find someone in the community or a group of people in the community that can work, that like your idea and think it works and think it's worth trying. And maybe I think it'd be better to work through community members. For me, if I were to go back, I'd probably try to start with people at the local clinics and get them to understand, convince, because they have some training anyway. Maybe talk to them about the causes of fluorosis, for example, and maybe what you really need is to get some buy-in and some enthusiasm from people in the communities. Otherwise, it's very difficult to achieve, I think.
Do they have access to some of the higher ranking community members? Do they have access to or do they know English, or could they connect with us via telephone or internet?
Well, it depends who you talk to. I mean, anyone who goes to school in Ghana, for example, they're taught in English. So anyone who's had any schooling knows English. It's the national language. So the less schooling they have, the less likely they are to speak English. They mostly will speak their local language.
Okay.
The people I mostly initially tried to connect with were the government workers. And of course, they've had schooling and they all speak English really well. And the thing is, there are mixed feelings about how much the government workers care about the local communities.
Yeah.
So the government workers sometimes do care, and sometimes they just give lip service about, oh, we're really trying hard to fix this problem, and they're not doing anything. So I found that to be a little frustrating too, that some government workers were a little apathetic. A lot of them weren't from the community. They were just, in Ghana, they're just assigned to posts anywhere in Ghana. And when the government changes, some of them are reassigned to new posts. So it's their job, and how much they care about the community I found to be a little bit mixed. I mean, I did tap on it. You spend enough time there and you find people who really do care. But I found it to be even better, and this takes time in the community, just to stay in the community and find community members who are respected and who really care. And then if you could work through them, I found someone who I worked through, and he really helped me connect with the community. Okay. And also his wife acted as a translator for me when I conducted my surveys, and they knew her, and she spoke English and the local language. So I think it's really, really important. And that's a real complicated part of going into a completely different culture and trying to help them. Mm-hmm. But one thing I found was I came in and I thought fluorosis was a big problem. And to tell you the truth, when I talked to people, it wasn't their priority. Because they could still, in this case, they could still work with damaged teeth.
Yeah.
So they were more worried about getting a regular income, because they were subsistence farmers. They farmed for half the year and then they sat around for half the year. And they were more interested in getting better access to water. So when I came in here thinking fluorosis was a big deal and something that mattered to them, I found it actually wasn't a very big priority, and most of them didn't even know about it.
Okay.
So that's an obstacle right there. And I thought, well, I'm telling them what their problem is, and they didn't really consider it a priority. They had other priorities like getting food on the table and getting water. Even if it had fluoride in it that was too high, they said, what are we going to do? We need water. So there are all these, I realized that I had to kind of reassess how I approach this. And that's when I said at the end of my paper, you really have to address the poverty, or some of the health issues are going to be secondary. I mean, they don't kill, dental fluorosis doesn't kill anyone,
Yeah.
In some countries where they have severe skeletal fluorosis, I don't know if you've looked at.
Yeah, also looking for.
They can't work. They're severely disabled. So that's really more serious, and they get it. In those countries, they're more likely to get that fluoride in the water is making them so they can't even walk. So the one good thing about skeletal fluorosis, though I wouldn't wish it on anyone, is it's so obvious. The problem is so severe in the parts of East Africa and parts of Asia that they've become crippled. But in the case of northern Ghana, at that point, it was still just dental fluorosis, and they could still work. It was just it would just damage their teeth.
So you didn't see many cases of skeletal fluorosis there?
I didn't see any documented cases of skeletal fluorosis. No, especially no crippling, because the concentrations of fluoride aren't as high in northern Ghana as they are in places like Ethiopia and parts of Tanzania and Kenya, and then India, Bangladesh, and other parts of Asia too, China. Have you looked at other places where they have cases of crippling skeletal fluorosis?
We looked at I think China and India were big ones.
Yeah, it's really, really sad. And I don't think Ghana's. I don't think the concentrations in Ghana will get so high as to cause crippling skeletal fluorosis. But they can still develop milder forms of skeletal fluorosis, which damage the bones. And I'm a little bit concerned just because of, installing more boreholes with higher fluoride.
I think that in India, or the acute toxic fluoride concentration was 30 milligrams per liter.
Isn't that awful?
Yeah, and in India, I think in one of the provinces, they had concentrations of up to 45 in their water. So
yeah, that's really, really bad. And India's done quite a bit of research on it.
Mm-hmm. Yeah.
And India's a more developed country, so they have a lot of people, and China too, of course, where they have a lot of people with advanced training and technology. So they've been addressing it for a long time. In Ghana, they just don't have as many people with the training or the industry, money.
Yeah.
But fortunately, I don't think we'll ever see fluoride concentrations as high as 10 milligrams per liter in Ghana. I just don't think the geochemistry and the hydrogeology is such that I don't think it ever gets above about 4.6.
Okay. Yeah. All right. And those are all the questions I have. Does anyone else have any questions?
Wait, so regarding location, why is it that some locations have higher fluoride concentrations than others?
That's a very good question. So in Ghana, which is the only place I've studied, the fluoride comes from the rock. Mm-hmm. So you have to be in a place where there is fluoride or fluorine in the rock. So in Ghana, there are pockets. It's not throughout, but there are pockets where there's a lot of granite called bongo granite that contains fluorine. And in my study area, you could go maybe half a mile and get out of the granitic area, and the fluoride concentration would be less than half of within the bongo granite area. So the highest fluoride concentrations in my study area were right in the middle of the bongo granite. Mm-hmm. So if they drilled a well right there, the concentration was over 3 milligrams per liter. But then you'd walk maybe a mile to the lower elevation flatlands. You could even see it. You could see the rocky area. You could even see the granite sticking out of the ground. It was higher elevation. You could see it sticking out of the ground. And you could even walk half a mile. The lower elevation, it was quite flat, more grassy. If you installed a borehole there, the concentration might be 0.5 milligrams per liter. Mm-hmm. So the source is that one area with the bongo granite, and as the water travels through the ground to a distant area, it starts to disperse. So in a way, it dilutes itself. It starts to spread into the wider area, and then just naturally, through physical processes, the fluoride concentration goes down.
Oh, okay.
So the source of the fluoride is just in pockets.
So I think sorry.
Yeah, in other countries, maybe the high fluoride rock is more widely dispersed, and they just can't get away from it. Like in Ghana, where I am, there are areas where you can actually get away from it, but maybe there are parts of India, which I haven't studied, where there's so much fluoride and the rock is just distributed everywhere that they really can't. There's no way of installing a well that's low fluoride.
I see. Because I was going to say, they might not be able to trust us, saying how we could filter water with bacteria, because that's really hard to, grasp. But I was thinking, maybe we could, the first step would be, what are, more secure places to sort of have these wells, if they're going to have wells at all. I don't know.
Yeah, that's a great idea, and I just submitted a paper with that recommendation. I just submitted it to a journal for review.
Oh, wow.
So our thought was, we were following your exact thought process. We thought, well, maybe the better thing to do would be install wells a little farther away, and then have the water pipe to an area where the fluoride concentration is high, and they would trust that, right? And the upfront cost could be quite high, because you have to somehow mechanically pump the water, which you need solar energy or something, and it would cost more to create the pipe system. But our thoughts were exactly that. Maybe we would put a borehole in an area that's a little bit farther away, and then pipe some of it to an area that doesn't have access to low fluoride water. And the upfront cost would be quite high, but then then actually can maintain itself for many years. I mean, once it's set up, it's not something that it's not like a filter that always has to be changed. Once it's set up, it's actually pretty good to go for years and years and years. So we started thinking that might be a better first step, as you said, because they're familiar with it. And the question always comes down to who's going to pay for it. The communities can't pay for it. I mean, installing a borehole can cost up to $10,000. So they're generally, they're generally $5,000 to $10,000, and then to have a piping system and to have have it mechanically, pumped out of the ground and moved costs even more money. So the question is, who's going to pay for it? Maybe an NGO could subsidize it. Ideally, it would be subsidized, in my mind, by the government to get it off the ground, but we just haven't seen that level of commitment from the government. They say they don't have the money. They may not have the money. We're just never sure, But I think that is actually, I think that needs to be an option. And for part of the year, some folks have recommended putting in little rainwater catchment systems at each house that would work for a little while. And they have short rainy seasons, so it wouldn't work year round, but it might work for a little while. But then again, the people have to be shown how to keep the water clean. The water being caught. They have to make sure that they do an initial flush, because collect it from the roof, right? So the stuff on the roof, they have to flush the roof first before they collect the water, and sometimes any extra step makes things difficult. But I know in some countries, there's some communities, at least I know someone doing this in Tanzania, which has a lot of fluoride. They've been actually encouraging people to install rainwater catchment systems at their house. But I think an alternative like what you suggest, I actually think that might end up being one of the better approaches, at least initially.
Yeah. I have a question about, I think I forgot it now.
It'll come to you.
That's fine.
You guys are really smart. You have really good ideas and really good questions. I actually hope what you're doing works out. It's a really great idea, especially another way of identifying high fluoride water. I mean, if we could find a better way, an easier way of identifying high fluoride water, that would in itself be really, really useful. Mm-hmm. Yeah, and it sounds like that's one of the things you're trying, right?
Yeah. We have something called sorry.
Okay, I remember the question. So we were looking into causes of excessive exposure in China, and one of the reasons was burning high fluoride coal. That was contributing to a lot of cases of skeletal fluorosis.
Right, I heard about that too, yeah.
Yeah, so in terms of do you know other means or modalities of exposure that are more dangerous than simply just naturally occurring, from the rock? Are there other ways of pollution that causes the excessive exposure?
Yeah, my understanding of that is pretty limited because of my study area is very rural. But I know it, like you said, in industry, it gets into the air. And so that's another source of exposure of things, maybe particulates, maybe, I don't know how they expose it. Maybe it settles onto the plants, I'm not sure, or breathing it in itself. Yeah. Also, tea really takes up a lot of fluoride. The tea plant itself takes up a lot of fluoride from the ground, so a lot of tea is very high. The tea leaves themselves are very high in fluoride. So of course, countries that drink more tea, and I actually tested some of the Lipton tea in Ghana, and it actually was pretty high in fluoride. So tea leaves. So like in Asia, where they drink a lot of tea, that might be another, unidentified. Well, it's not really unidentified anymore, but that's another route of exposure. Mm-hmm. Yeah. But the other sources, besides, I looked into certain food items. There are certain food items, the way they grow. It depends how much fluoride is in the soil where they're growing, but certain food items I found take up more fluoride. We didn't measure it in our study, but in certain parts of India and other parts of Africa, they measured in the peanuts and the green leafy vegetables, those can have fluoride in them. And then I mentioned the tea. And then I think there are other sources that I didn't study either, maybe certain types of pesticides. But so there are other sources definitely besides geologic sources. And then toothpaste, that's controversial in the U.S. Should we add fluoride to water? Should we add fluoride to toothpaste? Are they children getting too much? That's an ongoing problem in the United States.
In Ghana, do people brush their teeth, or was that?
They do. It depends. The very poorest people usually just have a chew stick. It works pretty well, actually. So they just have a chew stick that they chew on all day, and that helps to clean their teeth. Where I was living, the compound I lived in, a lot of the people had some kind of income outside of farming, and for those people, they all bought Pepsodent. Pepsodent was what everyone used. So yeah, they do actually are pretty good at brushing their teeth. But yeah, the very poorest people in my area, they wouldn't even waste their money buying toothpaste and a toothbrush.
Mm-hmm.
Yeah.
And is fluoride toxicity also an issue with animals living in ponds? Maybe the pollution from industry affects them. Is that a problem?
That's a good question. I don't know. That's a really good question.
Yeah.
I mean, I noticed in my study, for example, that canned mackerel can be a high source of fluoride, so it must be taking in fluoride from maybe the smaller fish it eats or something, because it's sort of up the food chain. I thought, canned mackerel can be a high source of fluoride, probably in its bones, right?
Yeah.
But whether or not it actually damages the animal itself, I don't know. That's a really good question.
Okay.
I should think it would, but I don't know.
Okay. Does anyone else have any more questions they want to ask?
Well, for when Maddie asked you what the best way is to put our mechanism into use, do you have any ideas for not for ethically, but environmentally, how we would actually use it in the water? Do you have any suggestions?
If it was a commercial product.
Yeah.
Yeah, I mean, I don't know how. You'd have to give me some details on how I can't picture how it's working. I mean, so what exactly do you do? I mean, you put some bacteria in the water, and what's the process by which you remove the fluoride, I guess? They got some high fluoride water, and then do you put the bacteria in it, is that right?
Yeah.
And then
if it detects the high fluoride, then it turns on. And
yeah, you can tell I'm not a biologist. So
yeah.
And then it takes there's a fluoride uptake involved, right? And then do they die? I can't remember what you said. Or do you just filter them out, or
we might need to have another sort of step in the filtration process to filter out the bacteria?
Well,
yeah, you'd have to filter them out. If you don't filter them out and people consume the bacteria, then they're going to consume the fluoride.
Mm-hmm.
So you're going to have to filter them out. It sounds almost like a biological absorption process. So you put something in the water, or co-precipitation. This happens the way we're moving it. Put something in the water, it takes it out of the water and puts it inside itself. But then the thing that it's stuck to or inside, you have to remove it so the people don't consume it. Otherwise, you're back to square one.
Yeah,
that's what I would think.
Okay.
So and you probably need a really fine filter for that.
Oh yeah, filtering bacteria, isn't it?
Yeah.
And that's also it's very, very hard for especially people to accept that, how we're going to put bacteria in your water, but it's okay, we're going to filter it out. Like, it's very hard to sort of get that idea.
Get that idea, right. I mean, you could just not tell them exactly how you're doing it. That might not be very ethical, though.
Yeah.
And also, like, since these developing countries don't really want to, like, I mean, we wouldn't know how to afford, like, another add-on to their filtration system, but actually, I don't know.
Yeah.
It's a lot.
It's a lot. And any kind of filter, the problem I found, any kind of filter, it's who's going to be responsible for maintaining it, who's going to be responsible for, it's not, there's going to have to be some collection of money. So that's why I started to think it might be better to do this, and this might be work in your case, it might be better to do this at a larger scale, like have a water treatment system.
Oh, yeah.
And then sell the filtered water really cheap that would be just for drinking and cooking.
That's a good idea.
And they're getting more familiar with using what's called sachet water. So I was in the Peace Corps in Ghana 20 years ago, and people would just put water in a plastic bag and put a rubber band around it and sell it on the street. And you don't want to buy it because you don't have no idea where that came from. But when I came back 20 years later, there are actually these companies, water filtration companies, and they would treat the water and put it in these sealed sachets, and you could buy these little 500 ml bags and sachets anywhere. I mean, you didn't have to carry water anymore. When I'd be at the bus station, I would just get some sachet water and drink it. It cost a couple of cents, and that was that. And they're used to buying sachet water. Now I'm starting to think that it might be more cost effective and have better quality control and better way of training people is if you had a larger, you actually had a treatment plant, a little treatment plant, and then maybe people could come with their big jugs and fill it up for a really low cost and then take it home, and then you would be in control of the whole process. You would have the filter system. You would be responsible for maintaining it. It wouldn't be decentralized like the water systems are. The more decentralized it is, the harder it is to control it. So my feeling is it's either that, or you could try to have little filtration systems in the home, and they would just filter the water as they use it. But I'm just not convinced at this stage that many people would actually do that. And that would be easier too, because you don't need to filter all the water. You just need to filter the water that they drink. Filtering all the water is a waste of money. Mm-hmm. So my approach has always been to find a way to get them used to having two sources of water. Mm-hmm. And that's, again, a little cultural change. But I see it happening slowly because more people are starting to buy septic. So... yeah, but I found it, I went in, I was really excited with all these ideas, and I spent a year in Ghana, and I just found all these complications that I hadn't even thought about. Little things.
Yeah.
So with what you're doing, it might be better to picture it on a larger scale. And to tell you the truth, if it's cheap, maybe some of these, well, I take that back. I was going to say maybe some of these companies with water treatment systems would buy into it, but I think they're probably already finding a source of water that's low fluoride to begin with. So they don't have to add that additional step. Mm-hmm. They just make sure it doesn't have microbial contamination and then sediment. So they probably just do a simpler filter process. They just find a place to collect water that's pretty low fluoride to begin with. But I tested those sachets, and most of them had almost no fluoride in them. So they were being treated somehow. I don't know if it was reverse osmosis or what. So this actually, I take that back. They might actually be interested then, maybe at a larger scale. So you could look at it at all different scales. Like, what would be the possibility of a home filter? Is that feasible or is that ridiculous? What would be the possibility of having something at each of the boreholes, which I'm beginning to think is maybe a little difficult. And then what would be the possibility of having it at a larger scale? where you just actually just sell the water at a really low cost.
Yeah.
But that's what I think comes down to, for me, addressing the poverty, because the people have to have at least a little bit of money to be willing to pay for a little bit of water. If they have no money whatsoever, they're just going to go to the local well and drink whatever they can get.
Mhm.
So, yeah, got a lot of layers and stuff. But in a place like India, which is more advanced, or other countries that are more technologically advanced, it might be an easier first step for you guys as well. And where it's a really critical problem too. In China, of course, so a lot of the countries in Asia just have a stronger technological base, and the problem is more urgent.
Yeah.
So it's pretty urgent in parts of East Africa as well. But some of those countries have a higher level of poverty, or less technically advanced.
Mm-hmm.
Yeah. So, yeah, sounds like a really good idea. You guys have to keep me posted.
We will.
Yeah, we will, definitely.
And if you have any questions, you can always email me. I'm fine with that.
Okay.
Okay, yeah, we will.
So,
All right. So, is everyone good?
Yeah.
So when's the competition? When are you?
It's
It's
in November.
5th.
No, 10th.
I'm sorry. What?
11th.
November
13th?
10th.
Okay. So you have some time.
Yeah.
Yeah.
Yeah. Good. All right. Well, good luck, you guys.
Thank
It's really,
you.
really a good job. Really a good project. I'm really, really fascinated by it.
Thank you.
So,
Thank you.
Thank you.
We'll keep you updated.
good. Yeah. Really a great idea. So, okay. Okay. Is that it then?
I think so.
All righty.
Thank you.